Alright guys, so in the last video we learned about what happens when two lines cross each other. We create an intersection point, and that point can be found by solving the two line equations simultaneously. Now lines only cross when the slopes m1 and m2 are different. If the slopes are equal, then we either end up with two lines that are parallel or two lines that are coincident with each other, one overlapping the other. And all these scenarios have something to do with the slope and the y-intercept. In other words, it's to do with the m value and the c value in your line equation. We're going to be looking at two different scenarios for lines that cross, one scenario for lines that are parallel, and one scenario for when the lines are coincident. And at the end of the video, I'll also provide a neat little mind map to help you guys understand the differences between all of them and how to identify which scenario you're dealing with. Our first line is negative x plus y equals 3. We can call this the first equation, and you can arrange it into the point-slope form as y equals x plus 3. When you draw this out on a graph, we can see the line passes through negative 3 on the x-axis and positive 3 on the y-axis. We're going to be using this line throughout all four scenarios and comparing it to the other line that's interacting with it. So for our second line, let's use x plus y equals to 3. We'll call this the second equation. You can also rearrange it as y equals negative x plus 3. Drawing this out reveals that the line passes through positive 3 on the y-axis and positive 3 on the x-axis. So it's creating a crossing maneuver. And by inspecting the graph, we can already see that there will be an intersection point at 0, 3. So let's confirm this using elimination to solve the two equations simultaneously. When you take equation number 1 and minus equation number 2, we will get negative 2x plus 0 equals 0, and that simplifies down to x being 0. Subbing that into the first equation, we find that 0 plus y equals 3, and so y equals 3, confirming that our intersection point is 0, 3. And since there are no other intersection points to find here, we can conclude that there is only one solution available when these two equations interact with each other. What makes this scenario special among the rest of them is that when these two lines are crossing, their slopes are different, but since they have the same y-intercept or the same c values, their intersection point is at the y-intercept itself. So if you know what these two lines look like on a graph and how they cross each other, you don't actually need to calculate the intersection point, because it's clearly just the y-intercept. Let's look at a variation of two lines crossing. Here we have x plus y equals 5. We will call this equation number 3, and you can rewrite it as y equals negative x plus 5. So this line will also be going downwards, crossing through the other line, but it passes through positive 5 on the y-axis. So clearly, their intersection point is no longer going to be on the y-axis. It's somewhere to the right. Using elimination, we find that the x value is 1, and subbing that into the first equation, the y value is 4. And so the intersection point for this is at 1, 4. So in summary, when your slopes are different and your y-intercepts are also different, there will be one intersection point only, but it will not be on the y-axis. And there is still only one solution for these two equations. Now let's look at a situation where the number of solutions change. Here we have negative x plus y equals 4. We will call this equation number 4, and you can rearrange it as y equals x plus 4. This is literally the same as equation number 1, but the line is raised up by 1 unit. And so the lines are parallel, going in the same direction, but never touching, never crossing, never intersecting. And this gets a little weird when we want to solve using elimination. We find 0 plus 0 equals negative 1. But 0 cannot equal to negative 1, right? They're two different numbers with two different values. So we would say that our calculation is false. And whether you want to use that calculation as your basis for an explanation, or use the parallelism happening on the graph, you can conclude to say that there are no solutions. So for a case where two lines are parallel with each other, the slopes are equal, but the y-intercepts are not. So for the final case, we're going to be looking at what happens when the slopes are equal and the y-intercepts are also equal. Negative 2x plus 2y equals 6. We'll call this equation number 5, and you can rearrange it as y equals x plus 3 when you simplify it and divide it by 2 and all that stuff. And you'll notice something here. The line is the same as the first one, which means that line number 5 is actually sitting on line number 1. They are overlapping through and through. When this happens, we call these two lines coincident with each other. If you attempt to use elimination for this, you need to first double the values in equation number 1, and subtracting that shows us we get 0 plus 0 equals 0. So 0 is 0, which is true. And all that means is that you're never going to find a specific answer because the answer is just everywhere. So we would say that there are an infinite number of solutions. So when two lines have the same slope and the same y-intercept, they are coincident with each other and have an infinite number of solutions. And now I'm going to build a mind map to show you how the connections are made so that you can identify each scenario in the future for yourself. The two most important principles to consider are the slopes, m1 and m2, and the y-intercepts, c1 and c2, from each line. The question is whether the slopes match or not, and whether the y-intercepts match or not. If you have two lines that can only give you one solution when you solve it, then these two lines must be crossing each other. And this only happens when the slopes are not equal. The y-intercepts can do whatever they want. It doesn't matter if they're equal or not. Just keep in mind that for our example, equation number 1 and number 2 falls under the equal case, where the lines intersected at the y-axis itself, while equation number 1 and number 3 falls under the not equal case, a very typical way of intersecting two lines somewhere around the Cartesian plane, but not necessarily on the axis itself. Now, if you have two lines but they don't have any solutions, that must mean that they are parallel. And this only happens when the two lines are pointing in the same direction or have the same slope, and their y-intercepts do not match. And this was the case for equation number 1 coupled up with equation number 4. And finally, if you're told that your lines have an infinite number of solutions, or you're asked to set it up in that way, then that must mean your lines are coincident with each other, which is when your slopes are matching and your y-intercepts also equal to each other. This happened when we coupled equation number 1 with equation number 5. So I hope this mind map made sense to you guys, and if you found it helpful, then share it with your friends, draw it out for yourself. If you guys can come up with a better way to visualize this, please let me know. And just a word of caution, the concepts that I explained in this video may not necessarily be used that way. What I mean is that most of the time, you're going to be asked to create a scenario where two lines are parallel, or where two lines might be coincident. And you may not even be given all the information to build those line equations in the first place. So that is sort of turning the concept on its head. And we're going to look at that in the next video on how to deal with the algebra behind this and learning to invent situations like this, because that is a realistic question you can get in your assessments. Alright, so I hope you guys enjoyed this. Let me know what you think down in the comments below on anything you feel I could have improved on or anything you would like to see me do in the future. Hit the like button if you like this video, share it with your friends, subscribe to the channel if you haven't done so yet by clicking the subscribe button down below, and ring the bell so that you can get notified for when the next video comes out. Thanks so much for watching, guys. Have a good one, and I'll see you next time.